Hello and welcome to our Fast Track to Contactless EMV Expertise course. This chapter focuses on contactless EMV on TTQ-driven kernels. In this lesson, we will look at processing restrictions, offline data authentication, and cardholder verification methods. We are reaching the end of the transaction now. What we have seen so far in terms of the transaction flow is that a card application was selected, the associated kernel was loaded on the reader. That kernel could be kernel 3, 6, or 7. The kernel got a decision from the card, as well as some additional data, and then the kernel optionally retrieved more data from the records. Those were all the steps that required the presence of the card and an interaction between the reader and the card. Now we are at the post-processing step, where the kernel makes sense of all the data that it received and performs additional checks before outcome processing. We saw in the first lesson of this chapter that the three kernels use slightly different processes for that step. Kernel 3 performs processing restrictions first, then offline data authentication validation, and finally cardholder verification. Whereas kernel 6 starts with offline data authentication validation, then performs cardholder verification, then processing restrictions, and finally terminal action analysis. Kernel 7 is simpler. It just performs offline data authentication validation, then cardholder verification. We also said that the order in which those steps are performed does not really impact our transaction analysis. We will now review the steps in no particular order and make sense of the data associated with each step. Let's start with processing restrictions. The concept is quite simple. Using data retrieved in the GPO and/or read record responses, the kernel performs processing restrictions to determine whether there are restrictions for the transaction. The elements that are checked include the application expiration date from tag 5F24 or 57. Typically, tag 5F24 would be preferred, but if it is not present, the kernel may extract the expiration date from the track 2 equivalent data. The elements also include the application usage control from tag 9F07 and tag 5F28. Remember that tag 5F28 is the issuer country code, which allows to determine if the transaction is domestic or international. The application effective date from tag 5F25. This is for kernel 6 only. And the application version number from tag 9F08. This is for kernel 6 only as well. The terminal may also check its exception file. This would be a file loaded on the terminal that contains a list of blacklisted PANs, either because the cards were stolen, or because they are known to be used for fraudulent transactions, or for any other reason. The terminal would decline transactions for cards with those PANs. So the concept of processing restrictions is quite simple. When a check fails, the terminal will either decline the transaction or force it online, and that's it. In order to do that, with kernels 3 and 7, the terminal would receive the card transaction qualifiers from the card, tag 9F6C. We saw that this is a bitmap, which, among other things, contains a list of actions and conditions. You can think of those as instructions left by the card issuer on the card. With those two kernels, the issuer may instruct any terminal to force the transaction that would otherwise be approved offline to go online for authorization if the card application is expired. So the terminal would check the value in tag 5F24 or tag 57 against today's date. And if the card application is indeed expired, and if that bit is set in the CTQ, it will force the transaction online. Likewise, the card issuer may instruct any terminal to fall back to chip insertion or to maxwrap swipe if the transaction is for cash or includes cashback. Those are the two possible restrictions for Visa and UnionPay. With kernel 6, the terminal would receive the card processing requirements from the card, tag 9F71. The concept is the same. If the card application is expired, the card issuer may instruct any terminal to either force the transaction online or to decline it, depending on which bit is set in the CPR. Checks on the transaction type are processed later in the terminal action analysis step for kernel 6. Let's now turn to offline data authentication. The general concept is that offline data authentication is implemented for readers supporting offline transactions and is performed for card-requested offline transactions. The kernel verifies the dynamic signature returned by the card and authenticates the data from the card. We covered the technical steps in details in the chapter on cryptography, and you can refer back to it if you want to. In this lesson, we just consider that the process may have been successful or it may have failed. Reasons for failure are not really important, but as we indicated, failure is typically due to a CAPK key not being loaded on the terminal or kernel, or to a key or certificate being expired. The success or failure is indicated by means of the appropriate outcome during completion. We have seen that there may be special cases where this happens even for online transactions, and that kernels 3 and 7 have a bit for that in the TTQ. Then the concept is roughly the same as with processing restrictions. When FDDA or CDA fails, the terminal will either decline the transaction or force it online. With kernels 3 and 7, the terminal would receive the card transaction qualifiers from the card, tag 9F6C, and this time we need to focus on different bits. The card issuer may have left instruction for any terminal to force the transaction online, even if the card approved it offline, in the case where it turns out that offline data authentication fails if the reader can go online. The card issuer may also have left instructions for any terminal to fall back to chip insertion if offline data authentication fails, if the terminal has a chip slot. So you can see, those are ways for card issuers to protect themselves if something looks fishy. With kernel 6, the terminal would receive the card processing requirements from the card, tag 9F71. And the concept is the same. Go online, decline, or fall back to chip if CDA fails. The next step we'll be looking at is CVM processing. The diagram we'll be creating may look a bit scary, but you'll see that it's not that complicated. We're starting with a contactless enabled terminal and a contactless card. When the transaction starts, the reader provides the card with the terminal transaction qualifiers. As part of this process, the reader indicates to the card the type of cardholder verification methods that it can process. We saw that those could include online PIN, signature, and consumer device CVM. So now the card knows what the terminal can do. Then there is transaction information, like the amount and the currency and so on. The terminal processes that and checks the transaction data against its own limits. Depending on how it is configured, the terminal might determine that it will only accept this transaction over contactless if the cardholder is verified. When that's the case, it can set an additional bit on the TTQ before it gives it to the card. The card would then be informed of what the terminal can do and of whether the terminal will require a CVM method. The reader also gives the transaction information to the card. This allows the card to run through its internal risk management process with the various sets of counters and limits that the card issuer would have put on the card. The card then provides a response to the reader, and it also gives it additional data. As we have seen many times now, with kernels 3 and 7, the card also returns the card transaction qualifiers. And with this bitmap, it can inform the reader of the type of CVM that it wants processed. It may require that online PIN be processed, or that signature verification be processed. It will not ask for something that the reader cannot do because it knows what the reader can do. If this were a consumer device instead of a card, it may also inform the reader that the cardholder was verified on the device. With kernel 6, the terminal would instead receive the card processing requirements from the card. And the process would be similar. If there is a mismatch, for example, if the card and the terminal cannot agree on a common CVM, or if the transaction amount is too high for the application, the GPO APDU would typically return an error status word. This could be to stop the transaction altogether, or to try on another interface, based on TTQ settings and card configuration. It might also be that the transaction needs to be restarted so that the consumer device CVM can be processed. Like we said, this makes for a scary diagram, but the concept is not that complex. The card and the reader are just trying to find a common CVM method so that everyone is protected. You should note that if none of those CVM bits in the CTQ or the CPR are set to 1, the transaction may be processed without cardholder verification. This is actually very common for low amount transactions. Just tap and go. The last step that we'll cover is terminal action analysis. This is actually an extended version of processing restrictions for kernel 6. Terminal action analysis is a mandatory step performed on kernel 6. The objective of this step is to complete additional checks on the kernel side to make a final decision concerning the current transaction. The kernel shall not perform this step if the decision taken by the card is to decline the transaction. The kernel shall check if some TVR bits are set and then, if they are set, shall determine the card recommendations. For example, this is where the kernel will verify if the information in tag 9847, the application usage control, allows for this transaction to be processed. For example, if this is a purchase with cashback, and cashback is not allowed on this application, then the transaction will be declined or forced online. This is also where the kernel verifies that the application is effective and if the application version number matches that on the kernel. We've reached the end of the transaction flow for a standard contactless transaction. You will have seen that the steps covered in this lesson are essentially to enforce the actions and conditions set by the card issuer in the CTQ or CPR. The results of those verifications will feed into the outcome processing step. The tricky part with contactless transactions is that all those checks happen after the card was removed. It means that if you look at an APDU trace, you will not actually see the result of this post-processing. With ContactEMV, there was always the terminal verification results to rely on to get the terminal's view of the transaction. And you could see its value because it was given fully populated to the card. There is no such thing with contactless for TTQ-driven kernels. If all you have is an APDU trace, you can see if the card declined the transaction, or if it requested to go online, or if it approved it offline. But you cannot see if the transaction was ultimately approved, because the trace will not show the results of post-processing. Quite simply, if you see on the terminal that the transaction is declined, or that it goes online for authorization, and if that status does not match the result in the CID, the logical conclusion is that the reader triggered on one of the bits in the CTQ or CPR. This concludes this lesson on processing restrictions, offline data authentication, and cardholder verification methods. Thank you for watching it.